Okay, let's go through the review one. First, I have to say these four are related to the homework one, question one. Okay, and in problem one, we have exponential distribution. Here is its PDF, and we want to find its mean and variance. Okay. So the problem one, we want to find the average of x. By the definition, this is equal to the integrate of x, fx x dx. We plug in the PDF of the exponential distribution. It is the x from 0 to infinity, lambda e to the negative lambda x dx. The first step, we want to do the change of variable. We let y equal to lambda x. So that means dy equal to lambda dx. Okay. So we do the change variable, we get the 0 to infinity y e to the negative y dy. And here have a 1 over lambda. Okay. Okay, and next step we want to use the integration by parts. Okay. So what we want to do is want to move this to be the e to the negative 1. Okay, this is because if we differential negative 1, we can get e to the negative y dy. Okay. So we can have the 1 over lambda sorry, 1 over lambda from 0 to infinity y d negative 1 negative e to a power negative y. Okay. And this from the integration by parts we can get e to a negative y to a power from 0 to infinity negative 0 to infinity negative e to negative y dy. Okay. And here have two negative. So we can change this to the positive. Okay. Okay, and for here, this term is equal to 0 e to negative 0 minus limit y to the y to infinity y e to the negative y. Okay, and this term is 0 because exponential go to 0 faster than y go to infinity. So the whole term is 0. And the first term is absolutely 0. Okay. So we have 1 over lambda this dy. And we know how to integrate exponential function. So it can be 1 over lambda negative e to negative y from 0 to infinity, and we get 1 over lambda. Okay. Okay. And next, we want to calculate the variance of x. The variance of x is equal to this square. We have known that this one is equal to lambda square, equal to lambda, 1 over lambda. So now we have to calculate this one. Okay, we have to use the same technique, change of variable and the integration by parts. Okay. So let's do this. By the definition, this can be like this, lambda e to negative lambda y, lambda x dx. We let y equal to lambda x. So it can be like this. Y squared e to negative y dy. Here have lambda square. Yeah. And then we do the integration by parts. So the same reason we put this from the inside to outside, we get e to a negative to a power negative y. So this can be square of 1 integrate from 0 to infinity y squared d negative e to negative y. Okay. And by the integration by parts, sorry, it can be lambda square over 1 y squared e negative e to negative y. Minus integral dy square. Okay. First we change the to negative to positive. And we want to move y squared from the outside of d to inside of d. So the dy squared is equal to 2y dy. Okay. Okay, and also this term is equal to 0 with the same result as the here. So I don't repeat it again. So this term is 0. So we have 1 over lambda square integral 0 to infinity. Okay, 2 y e to negative y dy. Okay, so now we want to integrate this one. And you can see this term is exactly the same as this term. And we have already can this term is equal to 1. So we can get this is equal to 2 over lambda square. So this term is equal to 1. Okay, so in the end we have variance of x is equal to 2 over lambda square minus 1 over lambda with power 2. So it can be is equal to 1 divided by lambda square. Okay. Okay. And let's do question 2. Question 2, we have the Poisson distribution. And we want to find its mean and its variance. Okay, and this is the Poisson's PF. The property. Okay, so the Poisson distribution is the discrete random variable. So that means this is equal to summation k from 0 to infinity k probability of x equal to k. So we have the summation here rather than the integration. We plug in the PF of the Poisson distribution, which is k factorial lambda to the power k e to the negative lambda. Okay, so we can find out this term can be cancelled. You can get k minus 1 factorial. And also you can see this term equal to 0 if k equal to 0. So from this we can get k from 1 to infinity with k minus 1 factorial lambda to the power k e to the negative lambda. Okay. And next we do k minus 1 here, and we can have lambda in outside. And you can see this term is equal to the probability x equal to k minus 1. So what we have is equal to lambda summation k from 1 to infinity. Sorry, I have to use blue. Lambda summation k from 1 to infinity probability k x equal to k minus 1. Okay, and this is equal to the summation k from 0 to infinity. Okay, this term is equal to 1. That is because the sum of the PF is 1. Okay, so this is equal to 1, and we can get the average is lambda. Okay. And the second part, we want to find the values of x. The values of x is, from the definition, is second over of x minus the first over of x with power 2. We know this one is equal to lambda. Okay, so this is equal to minus lambda squared. Now we have to calculate this. Okay, exponential of x squared from the definition is equal to k equal to 0 to infinity with k with power 2 probability x equal to k. We plug in the distribution of the Poisson, we can get k factorial lambda to the power k e to the negative lambda. Okay, but now we cannot cancel these two. We cannot do that. So what we do is we change this one equal to k minus 1 plus k. And you can see there's a magic. K minus 1 k factorial plus summation k equal to 0 to infinity k. Okay, the first, this term is equal to average of x, so that means it's equal to lambda. And this term, and we can cancel this term, these two terms, and we can get k minus 2 factorial. Okay, and you can also see that this term equal to 0 when k equal to 0 or 1. So we can get this equal to summation k from 2 to infinity k minus 2 factorial lambda to the power k e to the negative lambda plus lambda. Okay. So we use the same technique, k minus 2 lambda to the power 2. And this is the sum of sum of Pn, which is 1. So this is equal to 1. So we can get so this term is equal to 1. So we can get this is equal to lambda square plus lambda. So what we have is the probability of the variance of x is equal to lambda square plus lambda minus lambda square. Gets the lambda. Okay, that's the variance in the expectation. So the key is you have to make this to be the sum of the PAM. Then you can say this one is equal to 1. Then you can get the average of lambda and the variance of x. Okay. And for the question 3, okay, this one is the easiest one. We have x and y, they are independent. We want to find the smallest value of x and y is equal to this. We want to find this. We want to can this equation. Okay. So in P3, we want to find the minimum of x and y greater than t. Okay, find the probability. We know the smallest one is greater than t. That means x and y are all greater than t. So x is greater than t and y is greater than t. These two events are the same. For the independent, this is equal to, we can guess this. Okay. The joint of an event can be the product of the probability. Okay, so we got the probability. Okay, and that's all. And in the end, the probability 1 is important. You don't have to prove this, but it said, okay, sorry, this is this. If we have a two random variable, they are all Poisson distribution with parameter lambda x and lambda y. And if x is independent to y, then x plus 1 is Poisson lambda x plus lambda y. Okay, so that's all. Okay, thank you very much.